I have the for QR. Let me just put the scales here. So it's just put Q here. So 0.05, 0.1. So what we can do is just plot these two to check. We have already confirmed that QR coefficients are significant. So we want to find some similarity with the QQR and to use that as a confirmation for QQR. Remember, we need QQR because that gives us detailed insight than what QR does. If it does, then we also want it to be. So we can just make a simple, just a regular Excel line plot. Just a moment. So we insert any of these lines. Let me see. Maybe this is okay. Then what I can do is change this to pick the quantiles. So this is purely Excel stuff. Okay. So what would you say? The QQR is the one in, is it gold or orange? The one in orange. And QR is the one in blue. Based on this, would you accept the coefficients of QQR as being sufficiently significant? No, why? Yeah, it's not really. Normally, you can even have it. So this is what I. If you look at array, you feel that we need the intercept in this kind of way for the QR. Remember, the QR doesn't have the intercept. So, but forget about that for the moment. Look at the relationship that we are looking at. Doesn't need to have a suppose the BRB, okay, the BRB is denoted in, no, it is denoted in BRB. Okay, you can always find it and compare. But given that it's only this, also has no on. And it's denoted in Excel. But you can also change the denominations. This is actually not one error. And it's so it has two errors. If there is no testing race, there is no price when you stop. And if there is no parents, there is no price when you stop. So if this goes away, there is no explanation as to what this one will be. It has a dimension. It just like a class. So let's remove the intercept of the QR and try to get it better. So we go back to the code to remove the intercept. We agreed that to remove the intercept, you need to take 1. So we go to the QR, this QR, right? Subtract 1 from the, just take 1 out of the independent variable. If there are many, you put them by adding them by plus. When you get to the last one, you subtract 1, you will take the intercept out. Okay. So we can run that one. Did I change my working directory? Okay. Permission denied. What's it? Because the file is opened. Because I'm trying to write the same file. So I have to close it before I can write it again. Yeah. So I'll do that again. Okay. Now, when we go to, so now I want to replace this column. I want to replace the QR column. Go into our working directory and we open the, what's this one? 12. Oh. These are our coefficients now. Okay. The code. When? Here. I've forgotten. Great, thank you. Because then if you don't put it there, we'll still have that one. So we can open our new coefficients to realize that the new file has no intercept now. It is gone. So we can copy. We have to replace this one. So let's replace and see what happens. You see that now? The QR looks more like the QQR. The only difference is the magnitude. So they are similar now. So you can accept the QQR based on this. In the literature, this is the way we test whether you want to accept it. So that's what we are. So that's not a big problem because you don't expect the difference, the magnitude to be the same. But this is an aspect of it. So chances are one will be bigger than that. The main thing is that you want to be similar in how they describe the relationship. Sometimes, this is what happens. Sometimes the relationship is almost uniform. And sometimes you can have the PTR but no one has request. And no one can have request in the measure when you get apart from so what we may want to do now is to change. We have USBI. We have the yeah. So we can give it a title. We know this one is the ERVM CI what ISOF. Yeah. So we can leave it somewhere. So normally what I do is I keep all the plots in one file like this, so that later you can come back to them. Excel plots. Okay, very interesting. Okay, they are quicker to do.
But we can do this in R. We can do this in ggplot. With ggplot, so we'll do 1 in ggplot so that you see. Okay. So let's change let's do another one with the VIX and C. So it looks like we are agreeing on forgetting about the intercept. Yeah. Okay, so let's go to the code. So let's focus on checking with the quantile-on-quantile. Remind me that we should do the 3D plot before we proceed. Yeah. So let's we go down and change to what? So this is what you are changing. It's USVIS. USVIS. Yes, the QQR doesn't use the intercept already, so we leave that as it is. Then we can make this fix. I think that's it. Did we run this one? Just do it again to be sure. Then we run our QQR. It's fine. Okay. So that works. Let's try. So the last thing to save the outputs. So let's do. We don't need this guy again. We need it again, but not now. Let's close this. This one. And these are the files we want to use. Do our average. Put it here. Somewhere, we don't need you again. Yeah. Suppose, yeah. We can plot. Insert. That's covering where I can find. My plots. So insert. Okay. We use this one. And change this one. Select data. So with this, we should be wary of the QQR coefficients. They are not, to a large extent, they are not close to the QR coefficients. So this is PRVM. So what was it? USVIX. So you present the results anyway, and then you have to explain why we may not rely on the results because we can't confirm the significance of the QQR. So this is yes. Yes. So far in the literature, that's the only approach because QQR is semi-parametric. If it were parametric, then we can find its own p-values and t-statistic and standard errors to judge it on its own, but it doesn't. Okay. So far at the output, we've seen the coefficients. So, okay, you start with your descriptive statistics to explain towards the fact that a method like QQR is better because the data is not normally distributed. You can also determine different parts of the distribution as the market moves along, where we can determine hedges and hedges and diversifications and safe havens. Then we want to test for the significance of the coefficients. So we present the QR coefficients, we present the QQR coefficients. With the QR coefficients, you can tell whether they are significant or not. The signs are there, the magnitudes are there, which inform us of what to do in terms of investment and policy. Whether they are hedges, at what point are they hedges, at what point are they diversifications and safe havens. They want to go further to check the significance of QQR coefficients by taking the averages of each of them and comparing with the QR, and we make our conclusion so that we can rely or not rely on the results of QQR. The last thing is to visualize the QQR. In fact, there's only one thing you have to do. You just need to copy our 90 by 90 matrix, put it in that square bracket, and we run. That's all. That's how the code is. The code is ready-made. So, I can close this now. We need, we just need one of the, can do the first one. So